Hello everyone, this is Sakshi and I welcome you all to my tech platform Way to Learn. We are going to solve GATE PYQs and this is the part 7th of this PYQ marathon which is from mathematical physics. So let us solve the number 61st problem. You can also watch videos on revision on mathematical physics, classical mechanics and also on thermodynamics. It will be helpful for you before this gate exam, which is on Feb 6th. So I hope those revision videos will help you a lot for your exam. And do not forget to revise your formula notebook and write new formulas if you find in that particular notebook. So let us see the 61st question, which will be from gate 2013 mostly. This is from GATE 2013 and from matrices. A simple question, a lengthy question, but degenerate eigenvalue of the matrices. So we have to find the eigenvalue and we have to find which eigenvalue is degenerate. So degenerate eigenvalue is an eigenvalue which appears again and again. Okay, which occurs again and again. So we have to find which eigenvalue appears again and again. So here I'm not going to use the characteristic equation a minus lambda I equal to 0. I'm going to use this particular equation. So if you see my mathematical video on matrices, you'll find two or three more equations like that, and you'll also find more tricks on matrices, which will be helpful for you to solve the questions in the exam in few seconds. So you can use this particular equation in order to solve this question. So I have to find the trace. So I found the trace. And C11, C22, C3 are nothing but the cofactor, which is the minor of this C11. This is the minor of this particular term. C22 is the minor of this particular term, and C33 is minor of this particular term. So you have to add that, and you have to find the determinant. After doing all those things, you get a particular equation which is given by lambda cube, which is given by lambda cube minus lambda square plus 45 lambda minus 50. So let us see the next step. Okay, now this is a cubic equation. I have to solve this cubic equation and um, find my eigenvalues. So in order to solve the cubic equation, I'm going to use this particular method. So before that, I have to find, in order to use this particular method, I have to find one factor. So how do I find a factor without knowing anything? So I'm going to use like a trial and error method. So lambda is equal to 1 plus or minus 1, then lambda is equal to plus or minus 2. So I'm going to use lambda is equal to 1 or lambda is equal to minus 1 in this particular equation, and I have to see for which value this particular equation goes to 0. So on testing that, I get lambda is equal to gives me 0. So then lambda is equal to 2 will be a factor. So I know that 2 is a factor. Therefore, I use 2 over here. Now I'm going to use this method. I have written the coefficients of lambda cube, lambda square, lambda, and constant. So this should be the uh, like this should be the method for solving this kind of question. So now you have 2 over here. So I'm going to solve this. I have to write 0 in this first column, and then I add 1 plus 0 is equal to 1. Okay, so this is 1. Now I have to multiply. 2 into 1 gives me 2, and now I'm going to do like whatever is given according to the sign. I'm going to add it. Minus 12 plus 2 will give me minus 10, then 2 into minus 10 will give me minus 20, multiplication and addition, which gives me 25, then 2 into 25 multiplication and 50, this gives me 0. Since 2 is your factor, your remainder will be 0. So when you do not get anything 0, like remainder to be 0, then you can find that 2 is not a factor for your particular equation, or whatever you're doing is like a mistake. Okay, so you can check that. So now I'm going to use this constants 1 minus 10 and 25. I'm going to form a quadratic equation, which is lambda square minus 10 lambda plus 25 equals to 0. So I'm going to simplify this equation and I get lambda is equal to lambda minus 5, lambda minus 5 equal to 0. So therefore I get the other two factors, which is 5 and 5. So I have three eigenvalues and I have to find which eigenvalues occurs again and again, which is 5. Therefore, my degenerate eigenvalue will be 5. So let us see the 62nd question, which is from GATE 2013. And this is a kind of question like combination and permutation type. Number of distinct ways of placing 4 indistinguishable balls into 5 distinguishable boxes. So whenever you have such kind of situation, indistinguishable and distinguishable, you're going to use this particular formula. Okay, the number of ways is given by this formula. I'm just going to use this formula. So indistinguishable is m over here and distinguishable is n. So I have just used this formula and found number of ways to be 70. The next is the vector question from GATE 2014. The unit vector perpendicular to the surface. So whenever you have like sorry, whenever you have a question which says unit vector perpendicular or normal, you have to find n cap. Okay, you have a surface given, then this surface will be phi. You have to find del phi, and then you have to find the magnitude of this. So this will be the formula. You just have to substitute and put the points if it is given, and then you're going to get your answer. So I've just simplified this using this formula, and then I've just simplified according to the option given in the question. Next is from matrix, and a very easy question, maybe like a 1 mark question. So a matrix is given, and we have to find whether this matrix is orthogonal, symmetric, skew symmetric, or unitary. So these are the formula for orthogonal, symmetric, skew symmetric, and unitary. So I have found all these. I have found A transpose, A dagger, A dagger A, and I have seen which gives which satisfies this formula. So I have found that this matrix is a unitary matrix. Let us see the 65th question, which is from the complex. A very easy question, but you have to remember one thing in this question. So if you see, the question has an exponential term in the denominator. So if you remember my complex videos from mathematical physics, I have given like two formulas to find the residue. So the first formula is the one which we usually use for solving all the residue problems. But whenever you have an exponential term in the denominator, then I have said that we have to use this particular formula. So here if you see, this phi of z is nothing but z squared, and psi of z will be nothing but e power z plus 1. Okay, so you have to use this kind of formula whenever you have exponential in the denominator. Please do remember, because if you use the first residue formula, it will be like you will be getting the answer. But sometimes what happens is we get confused and we think that this question is a very tricky question and I cannot do this question. So this is not going to happen in the exam. So you have to remember this formula. A single thing that you have to remember about complex analysis, and a very simple thing. Okay, so you're going to remember this formula, and then all other things are the same. I'm going to draw the circle at the origin and radius 4, and I'm going to find the pole by using this denominator equal to 0. I get e power z is equal to minus 1. I can also write minus 1 in this form. So after writing this equate the exponents, I get z is equal to plus or minus I pi, 3 I pi, 5 I pi, and so on. So next step will be to find which of the following poles lies inside the circle and which does not. So you forget about this imaginary number. Consider only pi, 3 pi, 5 pi. Now you have to see which lies inside the circle. So obviously pi will lie inside the circle because 3.14 is somewhere around inside the 4. Okay, inside 4. Now 3 pi. 3 pi will be around 9. So therefore it does not lie inside the circle. So only I pi plus or minus I pi will lie within the circle. And if you see, there is no power given in the exponent. So it is a simple board. Now we are going to use this particular equation formula. Phi of z is z square and psi of z is e power z plus 1. But I have to take psi prime. So psi prime is e power z. And I'm going to use and find residue for plus I pi and minus I pi. So after finding the two residues, I'm going to use the Cauchy integral theorem and find the answer for that particular equation, that is particular function f of z, and I get 4 pi cube I. You can do along with me. You can check if you're getting the same residues and same answer. So next question is from differential equation. Very simple question. Very simple question. You have given you have a differential equation which is a homogeneous differential equation and very simple equation, and you have two boundary conditions and you just have to find the solution. So I mean, you have a homogeneous differential equation, simple thing, you just have to find CF, complementary function, y, which is solution. So I know m is equal to plus or minus 1, hence my solution will be a e power t plus b e power minus t. And then next step is to use the boundary condition and find the constants. So I have used the two boundary conditions and I found my constants value. So after finding that, I'm going to substitute the values of constant in y, and I get my solution to be y is equal to e power minus t. If you see the options, you have cos t, cos ht, sin t, sin ht. So I don't have any I imaginary term in my solution, therefore I'm going to use cos h and sin h. So I have used cos ht and sin ht, and on subtracting these two, I get e power minus t, which is equal to my solution. Therefore, y should be cos ht minus sin ht. A simple question. Next is Dirac delta function. Here you have to use the properties of Dirac delta. Simple thing, you just have to remember the property of a Dirac delta function. So now this is your question and this is the property that we are going to use. Just remember this property, a very easy property, and this will be very much helpful for you. Okay, so just remember this sum and the property also. Okay, just use the formula notebook, write in your formula. Okay, important property, and the steps that I'm going to tell will also be important. Okay. So now 0 to 3 t square delta of 3t minus 6 into dt is my question. Now I can see this. I can take 3 as a common. So I have taken 3 as a common, and this 3 acts as a constant c. So now I'm going to use this particular formula property. So on using this property over here, I get this thing. So property says that just I have to take the c and put it in the denominator. I have done that. Okay. Now remaining thing is that I have 1 by 3, 0 to 3 t square delta of t minus 2 into t. Now I have to see at what value of t my delta function gives me a spike. So at t is equal to 2, my delta function will be infinite. So at t is equal to will be my delta function will be infinite and it will rise up. Okay. So now the next thing that you have to find, what will be the next step is, now you know that at t is equal to your delta function will be infinite. Now what is your next step? You have to see that value that t is equal to lies inside your limit or not. So t is equal to here lies inside the limit. So if your t is equal to 2 value lies inside your limit, then you have to just directly substitute t is equal to 2 everywhere. So now when you substitute over here, you get t is equal to is 2 square and delta of t minus 2 will be 2 minus 2. This will give you 1 and this will give you 4. Hence my answer will be 4 by 3. So that is 1.33. And if your t is equal to does not lie inside your limit, that is if my limit is 0 to 1. Now this t is equal to does not lie inside the limit. Then your integral will be equal to 0. That will be the answer. Simple question. Just remember the property and how to use your Dirac delta function. Okay. So let us see the next question, which is from complex. We have to, like, it's a tricky question, but we have to go with the options. You have your function. Now, after seeing the function, basic thing we get is your option A. F of z has simple pole at z is equal to 0 and z is equal to minus half. Yes, I can say that. On seeing this, z is equal to 0 is a pole and z is equal to minus half is a pole. But then, they don't give us a question and these kind of easy options over here. So what we have to do is we have to check if they are simple, like if these poles gives us a finite value or not. A pole is one thing, which when you use that particular value in the place of z, your residue should be finite. Only if your residue is finite, then you can say that this is your pole. Okay, if I say like z is equal to 0 is a pole and is a simple pole, then I should know that this function will be finite function, that is the residue of this function will be finite when I use z is equal to 0. Okay, so now we have to check that thing. So using that option A, f of z is simple pole at z is equal to 0 and z is equal to 1. So I have found the residue at z is equal to 0. On doing that, I get a finite residue. So I can say that z is equal to 0 is a simple pole. This is correct. Now for similarly z is equal to minus half, simple pole is given in the option A. So I have to find that. When I find the residue, I get an infinite residue. Therefore, this cannot be a simple pole. So if you see, option C says that f of z is infinite number of second order poles. We do not know that. Okay, we cannot find it. So we can just take that option out. Next is f of z has all simple poles. F of z is all simple poles? No, because I have tested for z is equal to minus half and this is not a simple pole obviously. So I can say that option B will be right. F of z has second order pole at z is equal to minus half. Now we can also check that same thing. F of z has second order pole by using like if you take, if you consider z is equal to minus half as a second order pole, then what do we do for taking residue? See, if z is equal to minus half is a second order pole, then I'm going to take the residue. This z plus half the whole square and whole square will get cancelled. I do not have my function f of z as 1 by z plus half the whole square. But if I'm saying that this is a second order pole, then I should consider square term over here. So I have considered square term over here. And so on finding the second order pole, the residue, this is the following process. And on differentiating this particular term 1 by z into cos pi z, I get a finite value. Therefore, I can confirm by doing this. And I can say that z is equal to minus half is a second order pole. So let us see the 69th question. Here you have function f of x and g of x. F of x is e power minus x square and g of x is mod of x e power minus x square. So you have to see which option satisfies. So f of x is e power minus x square. This e power minus x square is continuous everywhere. Whenever you plot your whenever you plot your graph, or you can use this limit, LHS limit and RHS limit. When you solve problems for 12th standard mathematics, you would have done this, the limit problems, where you can use LHS limit and RHS limit and see if LHS is equal to RHS. When LHS is equal to RHS, then we can say that it is continuous everywhere. The function is continuous everywhere. You can also do by that way. So here, for g of x, it is mod of e power minus x square. So in a graph, if I consider x over here, that is x lesser than 0, then it would be minus x. And if I consider x greater than 0, then it would be plus x. So I have two functions for a single function. at x less than 0 and at x greater than 0. Obviously, when you use this LHS limit and RHS limit, they both will not be equal. Therefore, you can say that g of x is not continuous. Okay. So, in other words, I can say that if it is continuous, then it is differentiable, and if it is not continuous, then not differentiable. This is differentiable everywhere. This is not differentiable everywhere, because because this part is differentiable alone in this x is less than 0 region, and this part is differentiable alone in the x greater than equal to 0 region. So this is not differentiable everywhere. So f is differentiable and g is not differentiable. So let us see the next question, which is from GATE 2015, 70th question. So if you see, um, you have w is equal to f of, okay, you have a function u plus iv, and this is an analytic function in domain D. Okay, if I say this function to be analytic in domain D, then which of the following is not correct? Okay, now assume that function f of z is analytic. You have a real function and now imaginary function in that particular f of z. Then obviously you know by the properties from complex analysis that you would have learned in your semester, the second or third semester for mathematical physics. You would have learned that u of x satisfies your Laplace equation, harmonic equation, and v of x also satisfies the Laplace equation in the given domain. Okay. Similarly, it can be expanded. Okay, you can expand in Taylor series. You can expand the given function in Taylor series. Now, if you see, the option C says that in the limit z1 to z2 f of z dz is dependent on the choice of the counter between z1 and z2 in D. So it says that this function is dependent on z1 and z2 in the domain D. So I say that this function, this particular f of z, is analytic in this particular region, and this is my domain D. So this domain D, in this domain D, I do not have to choose a particular point from this is my z1 and this is my z2, and I have to say that only at this point my function will be like analytic or something like that. It can be analytic anywhere in this domain D. So it is independent of the choice of the counter. So I can choose my counter anywhere in this domain. So this option C will not be correct because the choice of the contour will be independent of the limit. So I hope you like understood many types of problems, different types of problems, and you have learned any. I hope you have learned something new from this video. So I'll meet you with more videos, and I'll try to be constant with my videos. So thank you for your support till now. So see you with my more videos, and also please watch my revision videos before the exam, so it will be helpful for you when you go into the exam. Learn from your formula notebook. So thank you.